Hello students, in this video I am going to explain you about random variables. Now, under this video we'll be discussing about what do you mean by random experiment, what is random variable with its types, then what do you mean by probability distribution of random variable and cumulative distribution function of random variable. Now let us start with the first point, that is random experiment. Random experiment is a process by which we observe something uncertain. After the experiment, the result of the random experiment is known to us. An outcome is the result of random experiment. The set of all possible outcomes is called the sample space. For example, tossing a coin. Tossing a coin has the sample space either only two sides, that is either head or tail. So S will contain only two samples, that is head or tail, that is called H or T. Second example, here you can see it's about rolling the die. So in rolling a die, the sample space S will be 6 sides, that is either 1, 2, 3, 4, 5 and 6. As we know that a die has 6 faces. Now what is random variable? Random variable is a variable that takes different values as a result of the outcomes of random experiment. Random variables are of two types. That is called, first type is discrete random variable and the second is continuous random variable. So what do you mean by discrete and what do you mean by continuous random variable, that we'll see in the next slide. Now what is discrete random variable? A random variable is said to be discrete if it is allowed to take only limited number of values which can be listed. For example, in a random experiment of rolling an unbiased die, the possible values that the random variable x takes can take the value from the list, that is 1, 2, 3, 4, 5, 6. As x takes finite values, it is called as discrete random variable. So the word itself suggests discrete. It's nothing but the values which can be listed down, which can be counted. Next is continuous random variable. A random variable is said to be continuous if it is allowed to assume any value within the specified range. For example, height of a person in centimeters, speed of the vehicle in kilometer per hour. So continuous random variable is a variable which assumes any value within the specified range. Now, next topic is probability distribution of a random variable. So, let x be a discrete random variable of a finite sample space, x. Let x1, x2 till xn be the values of random variable x with probabilities p1, p2 till pn. Then the function p of x equal to small x is called probability distribution or probability mass function of random variable x if it satisfies these two conditions. First condition says that probabilities of values of xi should lie between 0 and 1, where I varies from 1 to n. And second condition says that summation of all probabilities, that is summation I is equal to 1 to n, p of xi should be equal to 1. So if these two conditions are satisfied by the experiment, then only we can say that the given function is called probability distribution or probability mass function. In short, we call it as PMF of random variable x. Suppose, for example, here we can see that there are 3 coins which are tossed simultaneously and random variable x denote the number of heads. Then the possible values of x are either 0, that is 0 head, 1 head, 2 head or 3 heads. So your sample space will be either in all 3 tosses we get all 3 heads, we get all 3 tails, then otherwise HTT, we may get THT, TTH, THH, HTH and HHT. So these are the total samples of our experiment. Now What is the probability for x equal to 0? Now these are the values of x we have here. There is x equal to 0, 1, 2, 3. 0 stands for 0 number of heads. 1 is nothing but 1 head. 2 is 2 heads and 3 is 3 heads. So what is the probability of getting x equal to 0? That is, what is the probability of getting x equal to 0? Nothing but having no head. So here in the sample space we have to check the samples with no head, right? So here there's only one sample, that is called triple T, where we don't have head. So the probability for x equal to 0 will be 1 upon 8. Why divide by 8? Because we have in total 8 samples, correct? Now, what is the probability for x equal to 1? Probability for x equal to 1 means we want to find out the probability of getting one head in the experiment. So here we have to count the number of samples with one head. So here we can see that HTT have one head, PHT have one head, PPH contains one head, then that's it. So there are total 3 samples out of 8 which contains only one head. So the probability for x equal to 1 will be 3 by 8. Then what is the probability for x equal to 2? It is same as, again you have to count the number of heads in this samples. So here you can see that we have THH, HTH, HHT which contains 2 heads. So again there are total 3 samples. So probability for x equal to 2 will be 3 upon 8. Now what is the probability for x equal to 3? Probability for x equal to 3 means we are getting all 3 heads. So there is only one sample which we may get all 3 heads. So it is nothing but the probability for x equal to 3 will be 1 upon 8. Also, first condition we have done with the probabilities of all values of x. Now we will check the summation of all the probabilities. That is, from I is equal to 0 to 3. Probabilities of x I equal to 1. Is it 1? Yes. Why? Because we add the probabilities. So 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 1 is 8. 8 by 8 is 1. So here this is the probability distribution for this random experiment. We can see that x equal to small x. So values of x are 0, 1, 2, 3. And the probabilities for these values of x are 1 by 8, 3 by 8, 3 by 8 and 1 by 8. So this is called the probability distribution of x. So here you can see that as per the definition of probability distribution of random variable, my values of probabilities of for all values of x is lying between 0 and 1. And now if we take the summation of all these probabilities, it is coming to equal to 1. It means that this given function satisfies the property of PMF, that is probability distribution, or also known as probability mass function of x. Now here there are some questions for practice for you. First, question number 1 is, verify whether the following function can be regarded as PMF of the random variable x. Now, as we have to find out whether this function can be regarded as PMF or not, of this we have to check the definition of PMF. That is, we have to check as per the definition of PMF, we will be checking the property whether this function satisfies or not. First property says that probabilities of all values of x should lie between 0 and 1. Yes, here all probabilities are lying between 0 and 1. The next condition says that summation of all the probabilities should be equal to 1. Now we'll add all the probabilities. This is 0.1 plus 0.2 is 0.3 plus 0.3 is 0.6 plus 0.2 is 0.8 plus 0.2 is 1. It means that addition of all the probabilities is coming to 1. It means that here we'll see that as per the definition, this function can be regarded as PMF. Hence, it is verified as per the definition of PMF. Now, next question is, find the value k if the probability mass function of x is given as probability of x equal to small x equal to k into x plus 1 the whole square. X is equal to 0, 1, 2, 3. Now here first we need to find out value of k. As they have said it is PMF. So directly we can use the property of the PMF, that is summation of probabilities is equal to 1. By using this property we'll find out k. I hope you can solve this sum. Then question 3 is, let x be a discrete random variable with following distribution. Probability distribution is given to us in the table itself. We don't have to find out, just we have to find out probability for x less than 1. So what is probability for x less than 1? It is nothing but probability for x equal to 0. Then probability for x greater than or equal to 3 means probability for x equal to 3 plus probability for x equal to 4. Then probability for x lying in 1 and 4. Lying in 1 and 4, it means we just have to calculate a probability for x equal to 2 plus probability for x equal to 3. Then next is probability for x lying in 2 and 3. So here as we have less than or equal to operator, it means we have to include both the values. So it is nothing but probability for x equal to 2 plus probability for x equal to 3, that is 0.3 plus 0.15. The answer is 0.45. Next topic is cumulative distribution function. Now, what is this cumulative distribution function? Let x be a discrete random variable with values x1 to xn and corresponding probability values p1 to pn. Then, cumulative distribution function of x p1 is given as f of x equal to small x is equal to probability of x less than or equal to xi. Whenever there is a capital X, we call it as random variable x. And xi is, the small x is nothing but the value of that particular random variable x, where I is equal to 1 to n. This is the definition of cumulative distribution function. Now see the properties of CDF. Properties of cumulative distribution function. First property says that f of x always lies in 0 and 1 for all x belongs to capital X. F of minus infinity is always equal to 0 and f of infinity is equal to 1. If a is less than or equal to b, then f of a is also less than or equal to f of b. Probability of x lying in a and b is equal to f of b minus f of a. Now you can see the sums, the examples which are based on this. First question says, consider the following is PMF of x. Obtain CDF of x. Now it means that from this given PMF of x, we have to find out CDF of x. So how to find out that? That is nothing but wherein this we have to use the definition of CDF. So what is CDF? CDF is nothing but f of x equal to small x is given as probability of x less than or equal to xi. So f of 1 is equal to what? Probability of x less than or equal to 1, which is nothing but equal to probability for x equal to 1, which is equal to 3 upon 5. In the same way, we will find f of 3 and f of 5. So f of 3 will be equal to what? Probability for x less than or equal to 3, and f of 5 will be probability for x less than or equal to 5. Now question number 2. Following is a CDF of random variable x. From this CDF of x, you have to find out PMF of x. So again, from this CDF, we have to find out PMF. Again, the same definition of CDF you can use to get this PMF. Then you have to find out, after once you get the table of PMF of x, you will find the probability of x lying in 2 and 5. And you will find the probability for x less than or equal to 5 by x greater or equal to 3. For this case, you have to use the probability, conditional probability. That is nothing but probability of a by b. The formula for this is probability of a by b is given as probability of a at intersection b upon probability of b. Okay. Now here question number 3 is nothing but from a collection of 10 bulbs containing 3 defectives, a sample of 4 bulbs are drawn at random. Let the random variable x denote the number of defective bulbs. Find the probability distribution of x. Also find probability for x less than or equal to 1 and probability for x lying in 0 and 2. So experiment is very simple, where in case they are saying that there are total 10 bulbs, out of which there are 3 defectives, and out of this sample of 4 bulbs are drawn at random. So there will be total non-defective items, which will be equal to 10 minus 3 will be equal to 7. We have to find out the probability that x denotes a number of defective bulbs. So it means that x will take value either 0 or 1 or 2 or 3. And we will find the probability for x equal to 0, 1, 2 and 3. Once we complete that, we will get the probability distribution. And then from the table, we can find the probability for x less than or equal to 1 and probability for x lying in 0 and 2. I hope students have understood it. Please try these questions and solve it. If you have any query, please feel free to ask to me. Okay. Thank you. Bye bye.